I am Krishna Rao Patro, Associate Professor in the Department of CSC. So today we'll discuss about one important problem, that is how to implement linear queue using linked list. So in the previous session you have seen how to implement the linear queue in the normal array technique. Now we'll see how you can implement and how you can solve this linear queue problem using linked list. So you have write a program using Python. I hope you know what is queue. So when I say queue is a special data structure which follows first in, first out, FIFO. Queue follows FIFO principle. First in, first out. That means whichever comes first in, first out. So you have to maintain a list in such a way that whichever comes first, that you have to service first. So to solve this problem, you have to implement this FIFO order. When you want to insert, then you can call a special method called ENQUEUE. So the queue permits two operations. One is ENQUEUE. ENQUEUE means insertion, as well as second is DEQUEUE. DEQUEUE means deletion. DEQUEUE. So insertion always you have to do at the front. Insertion always you have to do at the rear part. And DEQUEUE means deletion. Deletion you have to do at the front part. These two operations you have to implement now. Okay. Let us have a simple linked list program. First, let me implement this ENQUEUE operation. That means I have to insert the data. So whenever I say using linked list, you have to create a node. Inside the node, you keep your data, and then in addition to data, you have to maintain one link also, because you are implementing using linked list. So every node will have two parts. One is the data part. Second is the link part. Okay. Data and link. The data can be a normal integer, or the data may be a simple character, or data may be any combination of any data. But the link is a special pointer which will be referring to the next node. So this is the structure of the node for your data. So now for every data you have to create a node. The node will be linking with another node. So whichever data comes, then you have to insert at the rear part. And whenever you want to serve or whenever you want to delete, that time you should call DEQUEUE operation. So during DEQUEUE operation, you have to remove the data. That means you have to process the data and remove it. So now our goal is implement insertion and deletion operation. Insertion for queue will say ENQUEUE, and for deletion will say DEQUEUE. Okay, ENQUEUE and DEQUEUE. Now see, here I have taken a simple example. ENQUEUE 10. That means first 10 will be inserted. ENQUEUE 10. And then ENQUEUE 20. So when you say first time ENQUEUE 10, what happened? The front will be here as well as rear will be here. So you have to maintain two indicators. One is front, second is rear. So the front and rear both are pointing to same place initially. Initially front here, rear also here. And when the 20 comes, 20 insertion means where you have to do? So you have to insert next of the first node. So that means 20 is inserted here. So it is pointing here. So that means my rear pointer is moving forward, but front is still there only. So rear is moving ahead. Fine. And the rear, which is always pointing to the latest node. And initially you do not know where the node is. And as it is a linked list, you have to maintain a special pointer called head pointer or start pointer. So this start pointer will be pointing to first node. First node's address will be stored in the start. So in every linked list, there is a starting pointer, but there is a head pointer. Fine. So Now here my question is what? Do DQ also. DQ means what? Wherever front is there, that node you have to delete. So here the 10 is the front side now. So the 10 will be deleted. After deletion, my front will be moving forward. So front is now coming here. And the start also pointing to next. So this node will be deleted. So automatically my start pointing to second node now. Now currently only one node is there because you have done DQ. Again you say DQ. So when you say DQ, again this node will be deleted. So front is going forward and front is also null and deleted also null. So this will be also deleted. So now both nodes are deleted, automatically start become null. Start become null. Again we'll say NQ30. So 30 will be inserted. 30 will be inserted and initially null. Again 40. 40 also inserted. This is null and this is pointing to this. So my front is will be here only, but the rear is moving forward. Rear is moving forward. Now if I ask display the data. Display the data. So assume I will again NQ50. So now 50 will be inserted at the end and the rear is moving forward. So currently 3 nodes are there. Now if I say DQ, if I say now DQ, what happened? Front element, which is now 30, that will be deleted. So the front will be moving forward. Front will be moving forward. Now if I ask display the data, so in the front part 40 is there, rear part 50 is there. So this is the present scenario. Means after doing all the operation, you will be getting 40 and 50 if you are displaying the complete queue. So this is what type of queue? It is a linear queue. So generally this linear queue you can implement in various ways. Using normal array you can do or using linked list also you can do. So today we will see how to implement this linear queue using linked list. So remember, so to do this, what are the various requirements? You need 2 indicators. One is front, second is rear. Front will be always pointing to front node. Rear will be always pointing to the last node. So you have to maintain 2 indicators. Front is what? One integer value. Rear also one integer value. Means the position. Generally that is the position. But in the linked list, what you have to do? Front it will be pointer which will be pointing to first node. And rear will be another pointer pointing to the last node. Fine. Now we have to implement this. Let us see through a simple diagram. Now see, initially the list is empty. Initial list is empty. Nothing is there. Now you want to insert 12. NQ12. So that means single node is there. So 12 is inserted here. So when your single node is there, that is only front as well as that is also rear. So front node is 1, rear also 1. And this is pointing to null. Now again we are inserting 24. So when you are inserting 24, where you have to insert 24? Wherever rear is there. Rear will be the last. So 24 will be inserted at the end. So this is also null. So 12 and 24. So 12 is available in the node 1, 24 is available in the node 2. Again assume I want to insert 36. 36 will be inserted at the end. So now here my rear pointer is available and here my front is available. So that means front node is 1, rear node is 3. Fine. Of course the value is 12 and value is 36. Node 1 value is 12 and node 3 value is 36. Fine. Similarly, remove. Remove means DQ. If you want to remove, which one you have to remove? You cannot remove in the middle or you cannot remove from the last, because the nature of the linear queue is always you have to follow a principle. First in, first out. So whichever element available at the front part, that you have to remove. Now here in the front part is 12. So when I say remove, only you can remove the 12 only. The first node you can remove. So after removing 12, 24 will become node 1. Then this 36 is node 2. So node 1 is now 24. Node 2 is now 36 because the first node is removed but deleted. So when I want to display the data, So I will get 24 as well as 36. So this is the way you have to get the output. Now you have to write a small program using Python. Now we'll write a Python program to implement this. So how to implement? Using object-oriented pattern. Define a class called node. In the node, I'll keep my data as well as I'll keep my next. Next is what? Is a pointer pointing to next node. And I'll pass the node as a data as a parameter whenever my node is created. So this is my constructor. So in the constructor I wrote this. So my node is ready. As and when I want to insert, then I will call this node. That means I will create an object of node. This object I have to insert at the end. Now this node part is ready. Now we'll write another class called queue. In the queue, I have to do my operation. What operation? One is enqueue operation, second is dequeue operation. When my queue object is ready, that time my constructor will be called. I will be maintaining two pointers. One is front pointer, second is rear pointer. Initially front is none, rear also none. So front is a pointer. Initially front pointer is none. And another pointer I will maintain rear. Rear also what? None. Why I am maintaining two pointer? Because in the queue you need always two indicators, front and rear. Front will be allowing you to delete and rear will be allowing you to insert. So using these two you can do all insertion and deletion operation in the linear queue. In addition to init method, I have to write a simple method called empty, whether queue is empty or not. If queue is empty, you cannot do any deletion operation. So during deletion time, you have to check whether queue is empty or not. So how will you check? If front is none, it indicates nothing is there. That means you cannot delete any item from the queue. Similarly, enqueue. So in enqueue, I will pass first my data. Whatever data I am passing, for that data I will create a node. So my node is created. If self.rear equal to none, self.rear is none, then self first time, because initially front is none as well as rear is none. So if at all first time you are coming, both are none. And if you want to insert, that time I will insert the new node. This temp is my new node. Whatever the node you created, that you have to insert it first time. Then return. Otherwise, if you are coming the second time onwards, that means if already node is there, then here self.rear of next equal to temp. That means first node next it will be attached the second node. So now rear is now at the second place, but front is at the there only. So my rear is moving forward. So during insertion time, rear is moving forward, whereas during deletion time, front will be moving. So here we are doing enqueue. So this next dequeue. In dequeue, I am checking whether it is empty or not. If it is empty, return. You cannot do anything. If it is not empty, my temp is moving forward. Self.front and self.front equal to temp of next. So my front pointer is moving forward. If front is none, then rear should be also none. So put a condition this. Because front is none means nothing is there. So put this. So using this way, you can do the means dequeue operation. Let us do a driver program. First create a queue. Then insert 10, insert 20. That means 10 and 20 are inserted. And call dequeue. So when I call dequeue, what happened? The 10 will be deleted because front pointer is moving forward. Now currently front is here. Again when you call dequeue second time, this will also deleted. So both the nodes are deleted. Now again insert 30, 30 is inserted. Again insert 40, 40 is inserted. Again insert 50, 50 is inserted. So at the end my rear will be at the last node. Front will be at the front. Now when you say q.dequeue, which one will be deleted? Wherever front is there. So my front is now here, because after deletion this is deleted, front is moving forward. And now when I want to print the data, front data is 40, and read data is 50. So this is the way it works. Now we'll write a program using our ideal environment to do this. Okay, let us do a small program for this. Now I have opened my ideal environment. There we have to type this program. I'll create a new file. My file is ready, and I have to enhance the window size. Option, configure idle. Here instead of size 10, I'll go for 29. Okay, apply. Fine. Now I hope it is visible. Yeah. Now here what I'll do, I'll define a class, because first of all I have to define a node. So define a class node. Node is ready. Here I have to write my constructor. Def underscore underscore init underscore underscore, and here I'll pass my self parameter followed by my data. Whatever data I am passing, that data I have to keep in the node. So I'll write here self dot data equal to data. So whatever data you are passing, you are keeping in the object. And self dot next equal to, initially nothing is there, so put a none. So my class node is ready. This node I have to use whenever I am enqueuing. That means whenever I am inserting the node or inserting the data. So let us define a class called queue. My queue class is ready. Which queue? I am going for linear queue. So in the queue I have to write my constructor. So write the constructor. So how to write a constructor? The constructor will be written with the help of a special method, that is init method. So write def underscore underscore init underscore underscore with the parameter self. Okay, my constructor is ready. Inside a constructor I have to maintain two pointers, front pointer and rear pointer, because these two pointers will be helpful to do my enqueue and dequeue operation. So I'll write here self dot front. Initially front is none, as well as self dot rear equal to none. So my initialization condition is this only. Later I will write one more method called whether your queue is empty or not. If queue is empty, you cannot do deletion. So I'll put a condition. What condition I should write? Is empty. Is empty. Is empty is my member method. So whenever you want to make a member, you should write self keyword. Self. Here I will check whether front is none or not. If self dot front equal to double equal to, you have to compare. So I will compare with none value. The none indicates nothing is there. So if it is none, then I will print a message, print queue is empty. Queue is empty. Simply also return queue is empty, return true. Otherwise, because here I am returning in the boolean value, true or false, else return false. Else return false. So my is empty method is ready. Now I have to write my enqueue and dequeue. So def I'll write my enqueue method enqueue. Here I have to pass my data because I have to insert the data. As well as I will make this as my member method of the class. I'll write self followed by the item. Whatever the item I want to pass item. In this method, I have to create the node first. So I will create a new node, or I will assign some kind of temp. temp is a new node. Temp equal to node within bracket whatever the item I want to pass, I'll pass here. So when I write this statement, automatically the control goes to this part. Here the object is created. So my node is ready. Once the node is ready, then I have to insert. Where I have to insert? I have to insert at the rear part. So initially I have to check whether list is empty or not. If it is empty, both pointer I have to initialize. So I will check a condition whether front, if self dot front equal to none and self dot rear also none. This indicates what? You are at the first time. So self dot front equal to self dot rear equal to the temp. So that means I am assigning this value to the front, and after that I will go out, return. Else, if it is not none, here what I will do? Self dot rear self dot rear dot next equal to the temp. So my temp is assigned this, and self dot rear equal to self dot rear of next. So I am going forward. That means my rear is moving ahead. So that means rear points to the last node. This is my, here you can print a message also, data inserted successfully. Similarly, you can write another method for deletion. So for deletion you would write dequeue. So I'll write here dequeue. These are all user defined. Dequeue. Dequeue this. So here what I'll do? Whether your queue is empty or not. If queue is empty, here I have to check. How will I know whether queue is empty or not? I can put a condition. If is empty, self dot is empty, if it is empty, you cannot do anything. If it is not empty, then I will go inside. Here I have written a method called is empty. So here I can call in the dequeue is empty. So self dot is empty. This is my method. If it returns true, then you cannot do anything. If it is not returning true, that means if it returns false, some nodes are there. So you can write in this way also. If it returns empty, then we can print a message. Yes, empty, you cannot delete. So you can print a message printf queue is empty. Queue is empty. This message you can display it. Okay. Otherwise, if it is not empty, then come to else part. Here you can print my queue will be, means front will be moving ahead. Self dot front equal to self dot front of next. So automatically the front pointer is moving ahead. So during deletion time, the front pointer you have to move forward, and during insertion time you have to insert the, means you have to move the rear pointer. So here I did this. Now if you want to display your data, so you can print method def print, and you want to make print data. So you can print a self, and you can start from beginning. So you can print a message temporary pointer t, T equal to self dot front. Self dot front. After knowing the front address, from front address you can go ahead until you reach the none. So you can put a condition while T dot next. T dot next not equal to none. Or if it is true, while T dot next is true, it can go ahead, and here you can print T dot data. T dot data. After printing the data, it should move forward. So T equal to T dot next. So but T is my temporary pointer. So keep on moving until you reach the end. But here if I write T dot next, then it will not display the last node. So instead of writing T dot, I will write simply T, so that it will display all the data. So until you reach the last node. Fine. So this way my program is ready. Now I will write my driver program. So here first of all I will create my queue. Queue is my class now. I will create one object, or I will write obj. So my queue is ready. See, I have given the name of the class is queue. So whatever the name you have given, that name you have to give. So this my queue is ready. Once the queue is ready, here I'll write here obj dot, I'll call my enqueue. So because I have to insert the data, so let me enqueue assume 10. So 10 is inserted. 10 is inserted. Of course, after insertion, let me display a message. After insertion, I will print a message. Enqueue queue inserted data subscription. Here I will print a message. Printf print data inserted successfully. Data inserted. How much? That value you can display the value item. Whatever data you are inserting. Okay. Now I can call again obj.enqueue 20. Now you can call what data is available. So you can call obj.print data. Let us call this Ctrl S Q program F5. Yeah. There is a small error here. Obj dot line number 35. Line number 35. Obj dot enqueue en. The naming must be written properly. Enqueue. Control C. Control def enqueue. Of course, you can write proper name enqueue. Enqueue means insertion. So here I will write here enqueue. Here also write enqueue. Control S F5. Line number 35 enqueue 10. Name sef is not defined. Name error. Self dot front and self dot rear equal to temp. If self dot front is none and self dot rear also none, then here self SCLF, that is keyword, self dot rear is temp. So while writing, you must be very careful about the keywords. If the keywords are wrong, then it will give the error message. Yeah. Now inserted. So now data. So finally displaying the 10 and 20. So this way you are able to insert. Now see, Even first time also, when the first time we are inserting, here also I can print a message. After insertion, I will print a message because it was not showing this one. Control C, inserted 20. Save it. Control S, F5. Yeah, first 10 inserted and 20 inserted. Now it is displaying 10 and 20. But here 10 and 20 comes in two different lines. Let me display in a single line. So to display in a single line, what you have to do? You have to write a next. This I'll write here, end equal to space. I'll give this space. And when the loop is over, I'll print a message, print, because at the end I have to display a cross symbol, because in the linked list you have to display in this way. Control S, F5. Yeah, so 10, 20 and 10. So this way you are able to. Similarly, let me delete. So whenever you want to delete, you can call the dequeue. So now you can call obj.dequeue. So whatever the name you given, that name you will give. So here DEQUEE. Better give this name. So here I am calling dequeue. So after deletion, the data should be displayed. Which data you are deleting? Because the front data you are deleting now. So here in the else part, here I'll write print self.front deleted. Remove data is whatever data you are deleting, that message you have to display. This comma. So the always you have to delete the front data. So write here self.front.data part, because the data is my component of the node. So that data you have to write. Now let us run it again. Control S, F5. Yeah. Now remove data is 10. So after removing 10, my linked list will be what? That you have to display again here. So here again you can call obj.print data. So that means you are able to do both the operation. Yeah. So now after removing 10, I got only 20. Okay. So this way you are able to implement. Similarly, again you can call dequeue. Let me write this. Again I am calling the print data. Control S, F5. Yeah. Now nothing is there. So that means the list is empty. Now if I ask again delete. If I ask now again delete. Here again I will call delete. Now currently nothing is there. F5. Yeah, queue is empty. So you cannot delete any more data. So whenever queue is empty, that time you can put a condition. Rear should be also none. So you can put a condition whether it is empty or not. While checking if it is empty, self.front is none, queue is empty, return true. At the same time, I will initialize self.rear also none. Self.rear is none. So it indicates that my both are pointing to none. Because your queue is empty. Because initially it was pointing somewhere. So whenever it is empty, you make it none. Now, if I ask to again insert, let me insert some data. F5. That is displaying fine. Now, after that, I may again insert 5, 6, 7. Here, if I ask obj.5, obj.6, and obj.7, means I am inserting 5, 6, and 7. So finally, I should get 5, 6, 7. Yes. Yeah. So Up to this it is empty. Now after inserting 5, 6, 7, my queue is having 5, 6, 7. Which is front data here? Front is 5 and the rear is 7. So now you can print a message. My content of queue. Here while printing, you can print a message. Print content of queue. The content of linear queue. So this message also you can display. Control S. Yeah. Earlier also coming, but always display proper message so that they will be knowing what exactly you are displaying. If they ask which is the first element and which is the last element, so how will you display? If at all you are interested to display front data as well as rear data, then you can display directly the content of front as well as content of rear. So let us display front node data as well as rear node data also. So let me display the front node data. So obj dot, I can directly print obj my object dot front, my front pointer, obj dot front dot data. So it is displaying front data. So here you can display front node data. Finally, what is the front data? Front data. Similarly, print, I want to display the rear data also. Rear data. Obj dot rear data. So this we also can display. So that means I am printing what is my front data and what is my rear data. Let me insert one more data, 5, 6, 7, 8. 5, 6, 7, 8. So my front will be how much? 5 and the rear will be 8. So let me run. Yeah, my front is 5, rear is 8. So at the end, I am able to retrieve all the value. Sometimes they may ask, what is the sum of all the value at the end? So how will you do? So what type of operation you do? They may ask, find the sum of all the elements of the linear queue. Sum of all the elements. So that means you can write another method called sum method also. Let me do the sum operation. So here I write just like print. I write copy. Here I write my sum data. So in the sum, initially the sum is 0 because they may ask what is the total value. Means I have to start from front and move on, keep on going till rear part. After taking every value, you have to add it. So initially the sum is 0. Start from front, go till none. So while t, so what I will do, my sum value I have to update. So sum equal to, so instead of sum is the sum keyword, so I will write s, or s is 0. Now every time I have to add it. So s equal to s plus t dot data, because from every time I have to get the value from t. So t dot data. So it is keep on adding to the sum, and the t is keep on moving forward. When the loop is over, then I should display the sum. So I can display sum equal to this comma the s. So now this sum data I can call now. So now at the end, let me call sum data, obj dot sum data. So now I will call this. Local variability is reference. Here it is showing some errors. Obj dot sum data. Now sum data itself, initially here I should assign the value t equal to self dot front, because I have to start from the beginning. Because if you do not know the address where it will start, that's why you have to initialize the starting pointer. So t equals self dot front and t dot data, keep on going until you reach none. So whenever none comes, you come out and print the sum. Okay. Local availability is re-reference. Line number 64 showing this mistakes. T equal to, not T equal to self dot front, because you have to assign the value starting address. Yeah, now sum is 26 because my values are 5, 6, 11, 11 plus 7, 18, 18 plus 8, 26. So this way I am able to retrieve. Okay, so you have to write the various methods on this, and they may ask a question: what is the time complexity for this insertion operation, and what is the time complexity for the deletion operation? Of course, insertion you have to do at the rear part. So in this case, it is fixed time. So that is order of 1. Time complexity is order of 1. Similarly, deletion where you have to do wherever front is there. So there also the time complexity is order of 1 because it's constant time. So whenever the operation takes a constant amount of time, that can be represented with the help of the Vigo notation order of 1. Fine. So this way you are able to see all the operations. So you have seen how to do insertion as well as how to do deletion, and how to display front data, and how to display rear data, and how to do the summation operation of all the data. So all kinds of operation you can do. Fine. I hope it is clear. So the remaining program will see the next session. So please practice well, and you will be knowing how to do this program. Because sometime in exam they may ask different operations. So whenever they are asking different operation, simply add it. Now here in this program I have added the sum data. Sometimes they may ask do some reverse display or do some other special operation on the mathematical data. So whatever the operation you want to do, always start from front, go till end. Sometimes they may ask you add 2 for every node. So what you have to do, take the starting pointer, assign to T, and keep on moving till last, and every time while updating before moving to next node, you assign the value. Assume T dot data equal to T dot data plus 2. That means what? I am adding 2 extra to every node. So this way you can do. Okay. So I hope it is clear. Thank you and practice well.
Like, share and subscribe. Hit the bell icon for more updates.